Hi, so in this we will discuss LeetCode problem 947, most stones removed with same row or column, right? So on a 2D plane, we place n stones at some integer coordinate points. Each coordinate point may have at most one stone, right? So a stone can be removed if it shares either the same row or the same column as another stone that has not been removed yet. Given an array stones of length n, where stones I means xi and yi coordinates of the position represent the location of the ith stone, return the largest possible number of stones that can be removed. Right. So suppose for this example 1, stones are placed 0, 0, 0, 1. So maximum I think 2, 2. Okay. So suppose take the a matrix 2D matrix of 0, 1, 2. Then maximum this column also 0, 1, 2. Okay, this is 0, 1, 2. So this is actually 0, 1, 2, 0, 1, 2. So first stone is placed 0, 0. Here actually I have actually stone. Then 0, 1 here actually. Then 1, 0, 1, 0. So here actually. Then 1, 2, 1, 2 here. Then 2, 1 here. And then 2, 2 here. Right. So which stone actually I can actually remove? Maximum number of stone I have to actually remove, right? So here actually how many actually total number of stones are present in this matrix? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. So total stones is equal to 6, right? So which stone actually I can remove? Suppose I want to check that which stones will be removed if I so this is actually one stone. This will be removed because it is sharing the same row. This also be removed because this is the same row it will share. Similarly, this will be removed because this is actually same column actually sharing this here, and same here also this will also be removed, and here also this actually same column is removed, so this will also be removed, right? So first these three will be removed. With these three are connected, and for this stone this will also connected. This row, this stone here also this stone is connected. This is sharing the same column. This also connected, right? So here actually you can see that total 6 stone will be removed, right? But at the last any one node I will not be able to remove, because suppose this is actually last node. They actually mentioned that we can only remove the stone can be removed if it shares either the same row or the same column as another stone that has not been removed yet. So suppose at the end this stone is actually still there, still present. So what will happen? There is no other stone, so I can remove this stone. That's why I can only remove 5 stone. Got it? So that's why answer will be 5. Got it? Why this is 5? Similarly for this example, how many actually what is the matrix size? Same 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So placed at first place is 0, 0, then 0, 2, then 1, 1, then 2, 0. This is 2, 0, then 2, 2. Okay. So which are connected? These are connected. These are connected. These are connected. Right. So if I want to remove this node, suppose, then this will also be deleted. This will also be deleted. This will also be deleted because this actually chained, interlinked, right? So for this, if I want to remove this, so how many actually node are will be deleted? Total number of deleted 1, 2, 3, 4, but one node one stone will not be deleted, so that's why 3 will be deleted, right? So if I want to remove this stone, is there any stone sharing this row or column? No stone in the same row and no stone in the same column, so we can't remove this stone. So I can only remove 3 stone here. Got it? That's the answer is actually 3. Got it? Got the logic? So what actually you're doing? First of all, I have to find the link actually. Link means which stones are interconnected, like same row or same column. So whenever I seeing, suppose I am actually traversing these actually stones, place of the stones. So first of all, how many actually row are there? 0, 1, 2, and column will present 0, 1, 2. Got it? So when I was seeing the first stone, I know, okay, 0, 0. So 0 row and 0 column will be interlinked. This is for row and this is for column. So 0 will have 0 row. Got it? Now 0, 2. So 0th row will have second column. So I can go from 0th row to second column. Got it? Now, and second row from second column I can go 0th row. Now from 1, 1. So first row, it will be connected to first column and first column will also connect to first row. Got it? 2, 0. So for second row will be connected to 0th column and 0th column will be connected to second row. Got it? Now 2, 2. So 2, 2 means this will also connected with second column and this will also connected to second row. So this actually our link. How can actually use this actually, this relation? So suppose I am in the row 0, suppose. So I will check that which column actually I can go. Which column I can go? 0 and 2. Got it? So 0th column I will go first. First I will go 0th column. So I will check which column actually, which row actually I can go. There are actually 2 stones. So these 2 will be removed. So these 2 will be removed, these 2 stones. Now I know, okay, this actually 0 row actually I can go. Okay, I have already checked 0th row, so I don't have to go again. So second row I can go. So now I'll come to this second row. Got it? Now I'll check, okay, which column actually I can go, 0 and 2. Okay, then I'll say, okay, 0 I have already visited. Okay, then now go to the second column. Second column, how many actually stones are there? 2. So again 2. Got it? Then I'll, okay, which row I can go? 0 I have already visited. 2 I have already visited. So I will not have to go any stone. So I will return from here. Got it? So I have also already visited these 2 column. So now go to this. Okay, I have already visited 0 and second row. Now go return from here. So I'll say, okay, 2 I have already visited second column. So I don't have to visit this again. Got it? So this actually 4 stone I can remove, but I will subtract this -1 ultimately at the end. Why? Because naturally 4 stones are connected, will be removed, suppose. Got it? So at the end, whichever stone will be present, that will not be removed, because there will be no any other, these 3 stone already removed. So there will be no same row or same column any other stone. That's why this will not be removed. So that's why -1. Got it? And in this actually I have to actually add all the number of stone I can remove, and this actually our answer. Got it? So just go to actually code actually. First of all, I have taken 2 map which actually for rows and columns. Which will first of all one rows for which column, that for which row, like for which row I can go which columns. Like for 0th row I can go which columns. Okay, so that's why for each row I can go actually multiple columns. So that's why this is vector of integer. And similar for the columns also. For each column I can go multiple row. That's a vector of integer. Okay, and another set means I have visited or not this position. So otherwise how will know that this 0th row or 0th column we have visited not, right? That's why I have actually taken this v rows which row actually I have visited. Right? So for each row I will start a visitation. Okay, first of build the relations. So I am traversing the stones array. I will check, okay, for which row and which column I am inserting. Got it? So rows of R will push back to column. and similarly for column C I will push back to R. Got it? Like from row which column I can go, similarly for from column which row I can actually go. Got it? This relation I actually built. Now what to do? For each row I will traverse only once. Got it? I will do what? I will find out that I will call the DFS function. What this actually give what? The how many actually stone I will be deleted from if I start from this current row. Okay, and I am subtracting -1 at the end, like whatever the total number of stones I got, and at the end -1. I have already shared the logic that why I am doing subtracting -1. Okay, so at the end return result. Okay, so I am got the rows and columns map and the visited set, which actually I used to not into to help to not fall into the loop, and then current row. Okay, so in now for this position result is equal to 0. Number of actually stones I can remove. Now I am inserting this current row into our visited set. That okay, I have actually I am visiting this current position. So that's the v of rows dot insert row dot second, means this is actually first time we are visiting. Okay, so what I'll do, result plus is equal to current number of column actually I have for this row. This stone will be removed, number of column, this actually number of stone are placed in the current row, right? So for each column I have to then again go to, so that's why first of all add the answer number of stones present in the current row. Then for each column I will actually check, okay, like suppose they're actually present as for 0th row I can go actually 2 and 3 column, second and third column. So for each column these two will be removed because this is in the same row. Okay, now I will go second column, from second column which row actually I can go. So that's why for column of rows of row like 2 and 3, so for second row I will check how many actually which row actually I can go for this from this column. So from column map I will find out that which row actually I can go. Suppose 0 will obviously go 0 and suppose 4. So 0 I will first go to 0. Okay, I'll check, okay, this is already visited, this will be actually false. Okay, so I will not be able, so it will return 0. Then I go to the actually 4th row, I can go to 4th row, this is not visited, so I will actually push this. Got it? So just traverse this. So that's why for each column I will check which row actually I can go. Got it? So first of all row to column, then from column to row actually I can go. Got it? That row I will visit. Got it? That row I will visit, and I call the same function where passing the current row I can go actually. Got it? And at the end return the result. So what is the time we should do? So how it is working? Suppose this is actually our let's take the example 0 0 0 0 0 2 0 0 0 2 1 1 2 0 2 0 2 2. Okay, so I have taken a map, row map and column map, right? So row map 0th row can go 0th column. Similarly for 0th column we will go to 0th row. Similarly 0 2, so 0th row can go to second column. Similarly for second column can go to 0th row. Then 1 comma 1, first row can go to first column can go to first row. 2, 0, 2, 0. Second row can go zeroth column. Zeroth row can go second row. 2, 2. Second row can go second column. Second column can go to second row. This is actually our this row map and column map. You can actually cross check that from which row I can go which column actually. Got it? This actually our indicates this, like from 0th row I can go actually 0th column and second column in this way actually. Okay, now what I'm doing, for each row I am actually traversing. Okay, so first of all 0th row actually I am traversing 0th row. So what I'll do, okay, I'll check how many actually how many actually column I can go. 2. So current equal to 2. Current, there is a 2 stone actually I can remove. Okay, so now what I'm doing, for each column I am calling the row function. So for second 0th row 0th column I am calling the how many which column I can go. I can go to 0th row. I have already visited, so I will not go. Okay, now what I'm doing, I am calling second row. I can go second row, so I will come here. Okay, second row. So I can actually it will be easy to understand the stack trace. First of all, it will be easy to, like, I am coming from 0, row is equal to 0. Now I am coming from row is equal to 2. Got it? Row is equal to 2. So this will actually return what? Row is equal to 2. Okay, there are 2 actually column I can go. So this will actually return okay, this actually currently 2 stone I can actually remove. So which column I can go? 0th column. So I have already visited this, so I will not be able, I will not go again. Okay, so this is actually second column I can go, second column. Okay, second column, this, so I will go there. Okay, so which column row I can go? 0 I have already visited. 2 I have already visited this, so this will not return 0 actually ultimately. So from here actually I got actually return 2, and this is already processed, right? Row 2. Now 0 I already processed, 2 also processed, and there is second column, second column. Okay, so this I will come. Okay, I'll go to the 0th row. I have already processed 0th row. Second row I have already processed this, so I will not call again. So again this will return 0. So ultimately 2 plus 2, this actually return 4. So this DFS function will return 4, and I have subtract with -1. So that's why current answer is 3. Got it? Now go to the actually next row. Next row is 1. Next row is 1. Next row is 1. So how many actual stone are there? 1. So currently 1 stone I can remove because 1 column are there. Now I go to the which column actually I can go? First column. Okay, then which row actually I can go? First row. So I have already processed this, so I will not call. So this will return 0, and I have already processed all the columns of this row, first row. So that's why it is return 1. So 1, it will DFS function will return 1, and I have subtract with -1. That's why this will 0. All right. Ultimately total answer will be 3. This 3 plus 0. Got it? What I'm doing? So that's why answer is 3. So what is triangular sort of this? Like for each stone I am actually visiting. So if there is actually m stones, so I am triangular sort will be m. I am trying to visit m. I will visit m stones. Right? Each stones once, because I am actually adding the visitation. So this will not be visit more than 1 to handle this, right? So triangular sort will be big of m, number of stones. Got it? And understood the logic also, right? Thank you.